Hey there viewers, I wanted to shoot a quick video on testing a map sensor on a Vortec engine. Now this is a 4.3 liter, and if we look here, this right here is our map sensor, and hopefully I have the camera pointed in the right direction. And this guy lives, if you look where my finger is, hopefully you could see that, he lives right back in that hole right there. Okay, so I got this, I got the middle wire back probed. It's the light green wire, and that guy is, if we look here at this, I'm going to try to get as close as I can. Hopefully you can see this on camera. Our map sensor, this is our map sensor. Our light green wire is right here, and this is the map sensor signal. And coming out, we have a 5-volt reference, which is our gray wire coming from the PCM, and then the PCM also is the black with white stripe wire is the sensor ground. So all of these connections go back to the PCM. And basically what we should see, so if you look at this test description, 4, 5, and 6, these refer to what's being done on this table over here, number 4, 5, and 6 here. And so do we have any, number 2 says any map sensor DTCs, diagnostic treble code set. There's none. We'll go to step 3. It wants us to compare to a known good vehicle the map sensor reading. Well, we don't have a known good vehicle, so what we're going to do in this step, we're going to ignore this value of plus or minus 0.4 volts. We're just going to get the key is on, the engine's off, with the key on, engine off, and we're just going to get what that reading is. So if we look here at our meter, we're reading 4.75 volts, and I'm hoping that you guys can see that. And then we're going to hook our mighty vac right up to this part of our map sensor, the part that goes down into our intake manifold. And what we want to see is a steady change. So I'm thinking, hopefully you can see both of these. I think you can. If we pump this up, we should see an instantaneous change. And so far so good. I'm just going to keep pumping him up, and it looks good from that standpoint. And if you read back over on this page back over here, it does state that the voltage change should be instantaneous. A slow voltage change indicates a malfunctioning sensor. And now we're going to pump this guy up to 10 inches of mercury. We're going to put 10 inches of vacuum, and it should cause the voltage to be 1.5 to 2.1 volts less than the voltage at step 3, which is our 4.75. Okay? Because on this over here it says there's that 1.5 volts right here. And it tells you to subtract the second voltage reading from the first voltage reading, which the first voltage reading is 4.75 atmospheric pressure, no vacuum applied. So we're going to go ahead and pump this guy up to 10. And let me try to position the camera so you guys can see it. Right about there is 10, so we dropped to about 3. I'll move this around a little bit. Hopefully one of those views you don't have a glare. So 4.75 minus our 3 is about 1.75, right? which is good. So that's a 1.7. So we're good with the voltage being 1.5 volts to 2.1 volts less than the voltage. So as far as this test goes, our map sensor tested okay. So I do want to note that this hopefully it looks like it's on camera. If you look here on this guy, this O-ring is starting to tear. I'm hoping that's not leaking. I'm hoping that's not causing a vacuum leak. Now, when I did about a month ago, when I had my smoke machine hooked up, there was no vacuum leak right there. This guy was not leaking anything. So I'm happy with that test. That guy tested good. And guys, I hope you found this video useful. Thank you for watching.